Question number 2. This is a question which appeared on the IBHL Maths exam. Again, the IB Higher Level Maths exam, paper 2 in May 2011. Okay, it was question number 2 on that paper, carrying a maximum mark of 6. We are asked to consider the function f of x equals to x cubed minus 3x squared minus 9x plus 10. X is real. We are asked to find the equation of the straight line passing through the maximum and minimum points of the graph. So first, let's go ahead and find the maximum and minimum points. To do that, these are turning points. So to do that, we have to find f prime x, which is the derivative of this function, and then set it to 0 to find the x values. Okay, that's the first step. Find f prime x, and then let's set it to 0 to find the x values where the turning points occur. So f prime x will be 3x squared minus 6x minus 9. Again, when you differentiate x cubed, you will get 3x squared. That's what you see here. When you differentiate minus 3x squared, you will get minus 6x. And when you differentiate minus 9x, you'll get minus 9. So for the turning points, let's set that equals to 0. So 3x squared minus 6x minus 9 equals to 0. And if you divide throughout by 3, you will get x squared minus 2x minus 3 equal to 0. Let's factorize. X minus 3, x plus 1 equal to 0. And therefore, from here, you can get x equals to 3 or negative 1. Okay, we have found the x coordinates of the turning points. Now, let's do f double prime x. So f double prime x, the second order derivative, differentiate f prime x, you will get 6x minus 6. That's what you see here. Okay, once you have f double prime x, the second order derivative, take x equals to 3, plug inside here. 6 times 3 is 18, minus 6 is 12, so it's positive. Therefore, we have a minimum point when x equals to 3. Take x equals to minus 1 and you plug it inside here. Minus 6 is minus 12 is negative. Therefore, you have a maximum point when x equals to negative 1. So minimum point when x equals to 3 and maximum point when x equals to negative 1. We need the y values. So take this 3 and plug inside here. So when you plug it inside here, in f of x, you will get 3 cubed will be 27, minus 3x squared will be minus 27, minus 9 times 3 is 27, plus 10, you will get minus 17. That's what you see here. So do the same for minus 1, plug in minus 1. When you plug in minus 1, you will get minus 1, minus 3, plus 9, plus 10. Okay, minus 1, minus 3, plus 9, plus 10. And you'll get 19 minus 4 will be 15. So that's what you see here. So we have the coordinates of the minimum point, 3, negative 17, and maximum point, minus 1, 15. We want to find the equation of the straight line connecting these 2 points. So let's find the gradient first. We'll use y2 minus y1 over x2 minus x1. When you do that, 15 minus minus 17 will be 32. And minus 1 minus 3 is minus 4, and you will get negative 8. So that's what you see here. So we will use y minus y1 equals to mx minus x1. Use any of the points. So I've used this point here. So y minus 15 equals to minus 8 times x minus minus 1 will be x plus 1. Clean this up and you'll get the equation of the straight line y equals to minus 8x plus 7. Part B show that the point of inflection of the graph lies on this straight line. So to find the point of inflection, you need to set f double prime x equal to 0. Okay, to find the point of inflection, set f double prime x equal to 0. So f double prime x is this one here, 6x minus 6 equals to 0, x equals to 1. So if x equals to 1, the y value will be go back to your original function, plug it inside here. Let's do the working here. So I have 1 minus 3 minus 9 plus 10. So I have minus 2 minus 9 is minus 11. Minus 11 plus 10 will be minus 1. So the inflection point, the coordinates will be 1, negative 1. So taking the equation of this straight line, y equals to minus 8x plus 7. When x equals to 1, plug that in. Minus 8 times 1 is minus 8 plus 7 is minus 1. Therefore, we have shown that this point, 1, negative 1, lies on the straight line y equals to minus 8x plus 7.